Okay, spinal cord structures and cross section. It's not very hard as long as you can tell anterior from posterior, dorsal from ventral, whichever you want to say. I'm in the habit of calling these structures dorsal and ventral. The textbook tends to call them anterior and posterior. For me, either is correct. So, first off, look at the orientation of the spinal cord within the vertebral column. Okay, so you of course know that the spinous processes are posterior or dorsal, so that's the back side. And then the body of the vertebra is anterior. So it's not very hard to tell how the spinal cord fits in there and what's anterior and posterior if you have a vertebra, but you don't always have a vertebra, so you've got to have some other ways to do it. So we'll get to those in just a second. Before we get to those, I want you to notice that the general pattern of the spinal cord is white matter, which is mostly myelinated axons on the outside, gray matter on the inside, which is different than the brain. Brain goes gray matter, white matter, and then some more gray matter. So, but for the spinal cord, white matter on the outside, gray matter on the inside. And then if we look at how the white matter and gray matter is oriented, you have some lateral, you have some posterior, you have some anterior. So what you need to be able to do is to figure out what's anterior and posterior without the spinal cord. So let's look at that. Okay, so if you were looking at a real spinal cord, this fissure on the anterior side, close to the body of the vertebra, is actually deeper. So it's called the anterior median fissure. And the posterior one is more shallow, and it's called the posterior median sulcus. Not super obvious from these pictures, so I wouldn't use that one. What is really pretty dependable is the shape of the gray matter. Okay, so stick with me. The shape of the gray matter, which to me looks kind of like an H or a swallowtail butterfly. I don't know if you guys know what a swallowtail butterfly is. So look at this, and then look at this. So notice that these pointy wings would be like these bottom wings. So if I like flipped this little guy right there and then said, doesn't that look kind of like this structure? The pointy bottom wings are always going to be toward the back. And notice that they come into contact with like the outside of the spinal cord, almost come into contact with the meninges. And that is true despite the fact that the spinal cord changes shape a little bit from the cervical region, still pointy butterfly with the bottom wings, the back wings toward the back. Thoracic region looks a little different, admittedly, but still pointy wings go toward the back. Lumbar region looks a little different again. Okay, so now let's start naming the parts. So once you get anterior from posterior, you can label the white matter based on where it is, and then the gray matter based on where it is. So let's do these first. So this would be anterior, right? Because this portion of the butterfly wings is anterior. So he's like flying forward. So this is the anterior portion. So we call these the anterior funiculi or white columns. For me, white columns is easier to spell and understand. What it is a whole bunch of white matter, primarily projection tracts going up and down. So you look at it in cross-section, but it's actually a column. So anterior white columns or funiculi, posterior white columns or funiculi, and then lateral white columns or funiculi. Either one is fine with me, so you can call them white columns or funiculi. And then there is some white matter that connects the left and the right sides. And that white matter is called the white commissure. Remember that commissure, a commissural tract, for instance, connected the left and the right side. So that's called the white commissure. So one more time with this. Anterior white columns, posterior white columns, lateral white columns, white commissure. So, and then the gray matter has a really distinct shape, even though, again, it varies a little as you go through. It's got a pretty dependable shape. Notice these anterior horns. The anterior ones are not touching all the way at the edge of the spinal cord, but the posterior ones do. So your swallowtail butterfly, anterior, posterior. So what do you call those? In the gray matter, the portions are still labeled anterior, posterior, lateral, and then you've got a commissure, but they're called horns. So I have anterior horns. Sometimes they call them anterior gray horns. Just seems redundant, but anterior horn, lateral horn, and the lateral horns really vary in how big they are from different regions. So you can't always see a super distinct lateral horn, but if you got something poking out to the sides, that's the lateral horn. And then this is the posterior horn. And then going from left to right is the gray commissure. Now, commissural tracts are, of course, white matter, but they're calling this the gray commissure because it's going from left to right, and it's gray. In the middle of the gray commissure is the central canal of the spinal cord. So one more time. Anterior horn, gray matter. Lateral horn, posterior horn, gray commissure. Okay? And you can see that pretty consistently in almost any figure. If you know what the gray matter looks like, you can kind of figure out anterior from posterior in pretty much any figure. Okay, now, so you basically need to be able to find anatomical structures in cross-section. And a dependable way to do that is the shape of the gray matter. Another dependable way to do that is the fact that one of these roots leading to the spinal cord has a ganglion on it, and the other one does not, okay? So one set of roots has a ganglion, the other set does not, and that is always going to be true. One set has a ganglion, the other one does not. You can't see this one. Let's see. Again, one side has a ganglion, the other does not. So which one has a ganglion to help you orient yourself? So no matter where you are, the posterior root has a ganglion. So it's called the posterior or dorsal root ganglion. Notice that the ventral root does not have one. So these two things that are directly attached to the spinal cord are called roots. Posterior root has a ganglion, the little lump on it. Again, posterior root has the ganglion. Posterior root has the ganglion, so you can tell that's the back side. No matter how many times you look, the posterior root has the ganglion. The posterior root, what we will figure out is that ganglion is involved in sensory function. And it has those unipolar neurons in it that are sitting in the ganglion that we looked at in the last, or in the first set of notes. So that's a good posterior landmark. A good anterior landmark is that the ventral root never has any ganglion, and then the shape of the gray matter also works. So you can use whatever you want, just make sure it's really, really dependable. So let's look at this figure, okay? I didn't label anterior or posterior for you, but you do have a way to tell, right? Because the shape of the gray matter, that's anterior, that's posterior. In addition, of course, this one has a vertebra around it. And so with a vertebra, you know that this structure is posterior and that structure is anterior. Okay, so that's spinal cord and cross section. Really the only thing that you need to do there is make sure you find yourself a really dependable way to tell anterior from posterior, and then pretty much everything is labeled based on anterior posterior directions. Okay, we will do spinal reflexes and the reflex arc next.